So this is how you solve question number 5 in the book. This question asks, a coin is 30 centimeters from the center of a turntable and slips when the velocity is 50 centimeters per second. What force causes the centripetal acceleration when the coin is stationary relative to the turntable? And what is the coefficient of static friction between the coin and the turntable? So for A, what force causes the acceleration? So that would be the frictional force, but it's static because it says when it is stationary relative to the turntable. If it was moving, then that would be kinetic friction. B, so we know that velocity equals 50 centimeters per second, which is the same as 0.5 meters per second. And we will find the coefficient of static friction. First, we can draw this scenario, this turntable, coin, and that is equal to 0.3 meters. And if we draw a free body diagram, we have the normal force, the force of gravity, and the force of friction. So if you sum up the forces in the x direction, you get the force of friction is equal to the centripetal acceleration times mass. And if you sum up the forces in the y direction, the force of normal is equal to the force of gravity because it's not accelerating up or down. And then you can solve this. The force of friction we know is equal to the force normal times mu equals mass velocity over the radius. Substitute the force of gravity, which is mg times mu equals mv squared over r. Cancel out the m's. And then you can substitute 9.8 meters per second squared times mu equals the velocity, which we're given as 0.5 meters per second, over the radius, which we're given as 0.3. Plug that in a calculator, and you get 0.085. And that's how I solve question number 5.